Welcome to this Forge College Explainer. I am absolutely thrilled to have you here today. We are wrapping up the real-world applications of blockchain module, which is a key part of your Why Blockchain, Philosophy, Trust, and Practical Value course in the Blockchain Fundamentals track. Now, in our last session together, measuring value and identifying limitations, we got pretty analytical. We learned how to quantify exactly where a blockchain makes sense and where it just doesn't. Today, we're taking those hard measurements and stepping right into the architect's studio for future directions and ethical reflection. We're moving from measuring the value of a system to drafting the actual mechanical ethical blueprint for its future. Think of this as the exact moment where abstract philosophy finally meets digital concrete. Let's get right into it.
So here's our roadmap for today. We'll kick things off with the immutability problem, then we'll look at encoding ethics into code. After that, we'll build an accountable DAO, check out hybrid architecture, walk through a 5-step workflow, and wrap it all up with designing for the future.
All right, first up, the immutability problem.
Okay, let's be real for a second. We all love the idea of permanence, right up until we make a massive mistake. Blockchain immutability is literally the gold standard for trust. But without safeguards, well, it's basically the digital equivalent of getting a terrible, misspelled tattoo. Or, accidentally hitting reply all to a 10,000-person company email, but forever. You can never, ever unsend it. And that brings us to a huge premise. Philosophical mismatches become real risks when systems are immutable. If your grand philosophy says, hey, everyone should have an equal voice, but your immutable code doesn't actually account for spam or malicious actors, you didn't build a utopia. You built a permanent disaster zone.
So how do we actually solve that? Enter one of my favorite mechanical gears, the revocation window. Think of this as a deliberate temporal limit encoded right into a smart contract. It's basically a bounded undo button. By adding this specific window of time where an author can still reverse an action, we're introducing a massive ethical constraint. We're basically saying, yes, this is going to be permanent, but not until the digital concrete has had a few days to set. It gives us that tiny, crucial window to fix glaring mistakes.
Moving smoothly into part 2, encoding ethics into code. This is honestly where the magic happens. We're moving out of the armchair philosophy and getting our hands dirty sketching these rules directly into Solidity smart contracts. We have to translate our lofty values into literal mechanical artifacts. Think about the state fields for a basic ethical policy contract. This is exactly how you draw responsibility in code. Policy author ensures we always know exactly who is accountable. Intent summary preserves a short human-readable reason for why the policy exists, so future generations aren't scratching their heads guessing our motives. Immutable creation stamps a hard time on it for audits. And boom, there's our revocation window, bounding that immutability. Ethics aren't just some glossy mission statement on a startup's website anymore, right? They're state variables right in the contract.
And the absolute crux of it is right here in this little line of code. ! Revoked, already revoked. This is the revocation guard. That philosophical choice we made to allow bounded reversibility, it just became a hard, unyielding rule. The contract checks if the revocation window has passed. If it has, that's it, it's permanent. The ethical debate is completely over, and the machine enforces the outcome. It's this incredibly cool marriage of human intent and mechanical execution.
Okay, section 3, building an accountable DAO.
To really ground this, let's look at a concrete case study. Imagine we're drafting the blueprint for a DAO, a decentralized autonomous organization, whose sole purpose is to hand out public good grants. Think about your master blueprint for balancing values. You've got the philosophical driver, the on-chain artifact, and the ethical trade-off. Take collective authorship. Great philosophy. Everyone gets a say. The artifact is open eligibility. But the trade-off? Open eligibility acts like a giant permanent magnet for digital spam. Or look at minimal censorship. We want open debate, so we store a public debate thread hash. But total openness invites malicious garbage, which means, you guessed it, we suddenly need off-chain moderation. Every single philosophical choice carries a mechanical cost.
Which leads us nicely into section 4, hybrid architecture. Because of those exact trade-offs we just talked about, especially the very real dangers of malicious content or leaking highly sensitive personal data, we literally cannot put everything on the blockchain. It's a massive design flaw to even try. So the solution is dividing the world into 2 distinct parts. On-chain, the immutable ledger is for cryptographic hashes, timestamps, attestations, and decision records. It's the bulletproof evidence that something happened. Off-chain, the messy, real world, is where we keep the raw data, the heated public debates, the sensitive personal info, and the nuanced human mediation. We use the blockchain to verify the off-chain world, not to store it.
We actually have a name for this concept, evidentiary permanence. And this is a huge takeaway for you today. In a hybrid system, you keep the permanent, immutable records, like a cryptographic hash of a final decision, on-chain for ultimate accountability. But the underlying messy raw data, that stays completely off-chain. So you get all the auditability and trust of a blockchain, but you keep the system clean, efficient, and honestly much more respectful of privacy and ethical boundaries.
All right, section 5, the 5-step workflow. So we've covered the theory and the mechanics. Let's pivot to the practical toolkit you're going to need for your upcoming capstone project. Think of this as the ultimate safety checklist for the blockchain architect before you pour any digital concrete. Step 1, identify your drivers. Are you building for anti-censorship, data sovereignty? Step 2, extract concrete, testable constraints from those drivers. Step 3, design the artifacts, figuring out exactly what lives on-chain versus off-chain. Step 4, specify accountability rules. Who is holding the pen? And finally, step 5, document the trade-offs and your acceptance criteria. If you skip these steps, you're not engineering, you're just guessing.
Let's zoom in on that 5th step for a second. Acceptance criteria. We need measurable, real-world signals to validate if our ethical trade-offs are actually working. We can't just cross our fingers and hope for the best. We need to say things like, okay, our open door policy is a success, but only if the maximum allowable spam rate stays below 5%. Or our dispute system works if we get successful mediation in 80% of appeals. These are the signals that tell us if our abstract philosophy is actually surviving contact with reality.
And finally, section 6, designing for the future. So it's time to wrap up this explainer and synthesize all of this. The absolute most crucial point to take away today is this. Ethics in Web3 aren't just feel-good mission statements, they are mechanical artifacts built directly into the smart contract. You have to translate your philosophy into bounded, testable rules. You've got to use accountable metadata to leave a crystal clear audit trail of human intent. You have to balance that awesome power of immutability with sensible revocation windows. And above all, always protect sensitive data by keeping it off-chain using smart hybrid designs. I want to leave you with one final provocative thought as you gear up for your capstone. How will your philosophy shape the code? What values are you intentionally or maybe unintentionally making permanent? Keep that front and center because in our next lesson, we'll be revisiting blockchain philosophy armed with all these new design rules. A huge thank you for hanging out with me for this Forge College Explainer. To keep building your Web3 knowledge and to dive deeper into this whole shebang, make sure you head over to forge.college. Keep exploring, keep questioning, and I'll see you in the next one.